And what I believe that only once you have a mathematical aspect of machine learning algorithms, then only you will be able to properly apply the machine learning algorithms properly for your problem. All right. Okay. So before we start, let me ask you a question. In the machine learning in general, what we have a set of input here. Okay. So let's say this is your input, and then you want to predict some output. All right. So based on these inputs, you want to predict their output. So in general, what kind of the outputs which we predict in the machine learning? There are three types of the output which we predict in the machine learning. The first one from where we in general starts our machine learning lesson, those are a regression. And the second output which we predict, those are a classification. And then there we have a third prediction output, and that in general we do their clustering. All right. So these are three output which we in general predict. And how do we do this? Let's say we have here input, which is in general also known as the data, input data, and then we have their output. All right. So what we do, we apply some kind of machine learning algorithm here. All right. Some type of the ML code here, and based on this ML code, then we apply this data is fed into this ML code, and then this ML code is transmitted there. All right. So after this, what we do, let me first set my microphone a little. I think I have some problem with the microphone. Anyway, so we apply then machine learning code, and then we feed our input data to this ML code block, and then finally it produces the output. And those outputs are three kind of output, like a regression, classification, and clustering. All right. So what is the relation between these input and output in case of the regression, which we will be discussing in this lesson? All right. So this input is known as a feature input, All right. And this output in general, we say that this is a target variable. And in machine learning language, feature input is represented with a capital X and output is represented with a small y. Then we derive here some kind of relation between x and y. So this relation established, once this relation is established, then we say that okay, our machine learning model has been trained. And once model is trained, that means this relation is established there, then we are able to give some kind of the input in the form of a feature input, and then we are able to finally predict the output. All right. So what are the use cases? Let's go ahead and discuss the use cases of regression. So the very first use case which comes in our mind whenever we start our machine learning algorithms in general, we start with Boston housing price prediction. All right. Boston housing price prediction. Now you need to understand this. This is not just only limited to Boston housing price prediction, but any kind of continuous value can be predicted with the linear regression. Only it needs relative data which have some kind of relation between the outputs and input, and then those kind of relation can be established there, and then finally the prediction can be made. All right. So this is not just only limited to Boston housing prediction, but you can say any kind of house price prediction. All right. So this is step number 1. And in step 2, I mean in the use case of 2, the use case of 2 could be the stock price prediction. All right. So there we have a stock price prediction. In the stock price prediction, in general, we have their input in the form of opening stock price, closing stock price, and total number of share or volume, and some other parameters, by using which we generally detects the final output, that is the opening of the stock price on the next day. All right. So what are the parameters on which the y depends? That's the mean stock price depends. Those parameters are recent history of price, stock price, and then any kind of global event happening. Okay. Any structural, you see there, any structural or organizational change within the company. Also you can say that the competitor performance also depends. Any kind of investment to that company, and some kind of related events happening across the world. Related event. And apart from these, there are many, the political events also affect some kind of, some companies, the stock price, and the political decisions, or you can say also the government's decision also affect the price, stock price. All right. Now let's go ahead and discuss the third one. The third one, which we can do like a tweet popularity. All right. So the tweet popularity predictions can be done something based on the previous history. You can predict the how many people are gonna retweet your tweet or anybody tweet. Let's say the Donald Trump tweeted something. Then based on the previous history, you can identify that how many people are gonna retweet this tweet. That's mean you can say the what is going to be the total the popularity or total retweeting counts for that tweet. And this tweet depends on many parameters such as how many followers are there, and of course recent history. Recent history means if tweets are gaining the more retweets previously, then it is also very likely that the most of the people are gonna again retweet it. All right. Then we have there number of followers of follower. See, this is kind of the chain in retweet. Let's say once a followers retweet a tweet, then the followers of followers are also gonna see those tweet, and then might the followers of follower also retweet. So this is kind of a chain. So those chain you can say there followers of followers and da 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 da. That's mean this is kind of then going to be followers, the followers of followers, and then their followers. Then you can say the effect is going to be kind of descending exponential, all right, something like this. So the immediate followers are gonna retweet more, and then the followers of followers might retweet less, and so on. All right. And then you can say there the kind of hashes. All right. So kind of hashes someone used, that also affects a lot. What kind of the things retweeted there, whether the people are gonna retweet or not. Let's say if something controversial tweet is there, then it's very less likely that the people are gonna retweet those. All right. And if something positive or some right decisions are made via the tweet, and that supports the larger interest of the people, then it is also very likely that those tweets are gonna achieve more retweets. All right. The fourth points here come emotional level. Emotional level, if I say, the many universities, especially the MITs and the some other universities which are advanced in the technology, they are working some kind of project where they take the CT scan and they scans the whole mind, and EEG, ECG, all those signals they take. After taking all those signals from the body, then they try to find out the emotional index of that people. The emotional index, you can say this one, emotional index as well. A emotional index means how much that people is sad or how much that people is happy. Otherwise, you can say this is a kind of emotional classification, emotion classification, you can say. But when we say the emotional classification, in that it will be a discrete values, some kind of emotion like angry, happy, surprised. But when I say the emotional level or emotional indexing, then it's a kind of continuous value. There I say, let's say the person is happy, then there will be their happiness level, let's say 1.1, 2.3 or 0.1, kind of that. All right. Now let's go ahead and get started with our the case study. The case study on which we are gonna work is house prediction. All right, so there we have a house price prediction. Now in this house price prediction, in general what we have there, we have X and then we want to predict Y. And in the form of X, we have many inputs. And in the form of Y, we have there one output. And this output is continuous output. All right. So there we have a continuous output and then we have the input, and input type could be continuous and discrete as well. So it's not always necessary that when you are working with regression, then the input also should be the continuous. Input could be a continuous as well as a discrete. So those many inputs include like area of house, number of bathrooms, number of rooms, the year that house built on. I mean, whatever input features you can think about the for house, then those will be used as an input, like you can say also crime rate in the city, and apart from that crime rate, you can say the literacy rate, and how many hospitals or universities or some other kind of things are present there. So those things definitely affects a lot while deciding the house price. For example, let's say when you are buying a house just beside some big hospital or a big university or some kind of a big company, then definitely the house price is gonna be high. But when you are buying a house in a countryside, then definitely the house price is gonna be low. So these input parameters decide what is going to be house price. All right, perfect. Now we have here, let's say we have X and the Y. The Y is one output, that's the continuous output. Now we have the two type of regression here. One type of regression is simple regression, and then the multiple regression. There we have a simple regression, and then multiple regression. All right, before I start ahead, let me take some comments there. Janmi Sheikh, thank you. And we have Gulame Raja. Hi bro, I can't find notebooks on your GitHub repo. Sorry for that one. The notebooks were available on my GitHub repository since it is not available since last few weeks. Actually, there is a strong reason why I had to remove those notebooks. There were few people who were misusing my video contents and notebooks together. And I had found out that those were being pirated, and apart from that, there were a lot of the misuse without in my knowledge. I mean, I am perfectly okay if you want to use it for your work and for the study, all those things you can definitely use. But the things is not right when you try to download all the codes and the videos together and then you try to sell it to someone by saying that it's your code or it's your video. So what happens, this is the very unique kind of YouTube channel where I had made videos from the very basics, from the Python to the TensorFlow, deep learnings, and then NLP. Even the videos, NLP videos, you can't find the videos like I have made a lot of the videos on the NLP. So those type of the videos are not available on the YouTube. So what people were doing there, the people were downloading the video and they were combining with the notebooks, and then they were selling it into their, the local college or kind of those places. But my intention was to provide all those things free without any misuse. But the day I found out that there is a, the misuse is being happen, so I had to remove those, and I'm extremely sorry for that. Anyway, you can follow along with the videos, and then you can get started working. All right. So now here we have simple regression and multiple regression. Now let's go ahead and understand what is a simple regression. All right. So the first we are going to describe here simple regression. A simple regression is a kind of regression where there is just one input and that one input is being used for output prediction. So you can say that one input and then you have their output, and that one input you can take anything. Let me draw here a plot. So there, let's say we have some line here. These are the, you can say, the price of the house. All right. Then we have here a line, and this is house area, and let's say there we have a price of that house. Now we want to predict this price based on this house area, and you see as the house area is here increasing. All right, so as this house area is increasing there, you see there the price is also increasing along with this regression line. So this is a simple regression. But let's say when you have multiple outputs, so there we have just a single output, but let's say you have got there one more input, actually house area. Along with the house area, let's say you have got their number of bedroom. All right. So once you have got the number of bedroom, now it becomes 2 input and 1 output. Let's say, let's go ahead and see what will happen in that case. All right. So there we have a multiple regression. So in multiple regression, what we see here, multiple input. When I say multiple input, that's mean more than one input. All right. And then finally, we have here y, which is output. So based on these multiple inputs, we predict this final output. All right. Perfect. So what happens here in case of this multiple input? Then let's say, let me draw here a graph first. All right. So there we have a price of house. Let's say once again, we have here house area, but along with this house area, we are also going to have here a third input parameter. And let's say the third input parameter which we are going to have here, that is going to be here number of bedrooms. All right. So this is going to be kind of multi-dimensional. Instead of plotting it here, let me plot it here. All right. So there we have number of bedrooms. All right. So let me delete this one here. Perfect. So with this, what we get, there you see once again we have got house area and number of bedroom. Now these two inputs have become a multiple input. That is why whenever we predict output, that's mean the price of that house, then we are going to use bedrooms and house area, and then in this case it will become there a multiple regression. All right. Now let's go ahead and start discussing with the regression first. All right. So there I am gonna discuss first here. Simple regression. All right. Now before we start discussing this simple regression, you need to understand that how overall this machine learning code or algorithm works together. And this is really very important to understand. Let's say here, sorry. All right. Sorry. So there we have there our input data, that you can say a training data as well. So this is the input data, and if it is raw input data, then that should be converted into input features. All right. And once you have their input feature, then we have here ML code. All right. So now you have ML code. With this ML code, you have a final output that you can say the y hat here. This is y hat. But what do you think that? I mean, this is this gonna work like this straightforward? I think it will not work, because it also needs some kind of input so that it can improve its weight. Then this output, this is actually, you can say, the predicted output, all right, get compared. Let's say here you can say the error generator, that's the error generator, and there you have y, that is the true value of y, and this y hat output, that is the estimated or a predicted output. All right, so their error comes here. So that error becomes like y minus y hat. And then based on this error, what happens? Their weight changes happens in this ML code. All right. So there you can say weight changes. All right. So the weight changes there based on error. A larger error means there will be a larger weight change. So the larger error means there will be a larger weight change, and a smaller error means there will be a smaller weight change. Alright, so this is how it works. Now let's go ahead and take it in the form of a graph and then see what happens once we start with the graph. Let's say alright, so there we have simple linear regression model. Alright, and the first of all, I'm gonna take here a house area as an input. And then we have their house price. Now I'm gonna just give here some points, random points. All right, so let's say this is a random point, and then the task is to fit a line here, a linear line, which can predict the output there. All right, so there could be some kind of relation between the house area and the price. Their price is parameter y, and this house is x here. All right, so what we get here, we get a function, let's say fx, a function fx is equal to w0 plus w1 into x. So w0 plus w1 into x, this is intercept. And here w1 is, this is regression coefficient. And this intercept means this is here intercept, this is w0, and this w1 is also known as the slope of this line. All right, So the slope of this line is known as a W1. When there is no slope, that's when there is no slope, that's when if it is just a straight line like this, then in that case, when it is like this, then W1 will be 0. And when this is completely like the vertical line, and then in case of that one, W1 will be infinite. So in general, these two cases doesn't happen. So this slope, either slope is positive or otherwise slope is negative. So this makes that positive slope, and this one is a negative slope. So when positive slope, that's mean the price is gonna increase, but when negative slope, in that case price is going to be decreased. All right. Okay. So this is about a simple linear regression. But let's say once you have a complicated data, now let's say you have a complex data, then what happens? Complex data. Do remember, still we are talking about here a simple linear regression. So when I say a complex input data, that's mean we only data do not have in a straight line, but we have data some kind of in curved line. All right. With a straight line, now if we fit this, let me first write here. Let's say we have a price here, and once again we have house area there, and now we have their price and house area. If we fit here a simple linear line, then we will get something like this. But now my question is, it right? Perhaps it is not, because it is not just showing here a straight line, but there is some kind of a polynomial fit here. So in this case, we cannot just use simply y is equal to ax plus b formula. This is kind of just simple line formula. So that is not going to work here. That's when we need to provide here some kind of polynomial formula. And when I say the polynomial formula, then you can, let me first make it like this. That would be something like this, let's say. All right. So in this case, I'm going to represent here this black line. So there will be new fx here. This new fx will be w0 plus w1 into x plus w2 x square. All right. So in this case, what happened there? Now we have here a polynomial fitting. So this polynomial fitting makes sure that we only not fit here a linear line, but also we try to fit there a polynomial fit so that it can fit properly. But let's say if you have something fitting like this, then how would you do that? So with this, you can even increase the polynomial, the degree. So there you can say fx is equal to w0 plus w1 into x plus w2 x square plus w3 x cube and plus dot dot. So that is going to be a polynomial fitting. All right. So how do we work with these polynomial fitting? So let me once again write here a formula. Fx is equal to W0 plus W1x plus W2x square W3x cube. All right. So in this case, what happens? In general, we know that this is the formula which we fit. So at a greater extent, what we do, we take these x2, x3, I mean x square and x cube. Let's say you have plus dot dot. So we treat these as a different feature. So these and these all right. Now in this case, we have here a feature 1 that is just simple constant feature, and we have then a feature 2. In a feature 2 we have x, and in the feature 3 we have x square, and for a feature 4 we have x cube and dot dot. And what are the parameters for these? For a feature 1 parameter we have a W0, and then we have here a W1, W2, W3 and so on. Alright, so this is how we can work with the polynomial regression. Alright, so this is all about in this lesson. Thanks for watching. From the next lesson, I'll talk more about the polynomial regression, and then I'll also talk about more how to how to fit these lines, and how these errors are reduced there with the gradient descent formula. So thanks for watching. I'll see you in next lesson.